Assalamualaikum. Here's the problem. First of all, we need to observe the problem. The problem is the rotation of the gear is controlled by the horizontal motion of the rack AB if the piston rod has a constant velocity x dot is equal 300 mm during a short interval of motion. Determine the angular velocity of the gear and the angular velocity omega AB of AB rack at the instant when x is equal 800 mm. So here is x, here is a piston which is moving linear direction and gear is moving circular direction. Okay, first of all we make the free body diagram, which is this. The first diagram is displacement diagram and the other diagram is velocity diagram. We make velocity diagram from displacement diagram. Okay, here you see it make 90-degree angle. So PA is base, this is perpendicular and this is hypotenuse. So our first step is to find the angular displacement, which is theta. By using the sine relation we found the theta. Sine theta is equal perpendicular our hypotenuse. We see the perpendicular 200 mm and hypotenuse is 800 mm. So we found the theta. So our next step is to find the distance PA. This is base by using cos relation, which is equal base over hypotenuse. So we know the hypotenuse and the theta. So hypotenuse multiplied by cos theta is equal base, which is PA. Okay, so our next step is to find the velocity VP. Here you see it's make 90-degree angle. So VP is base, VA is hypotenuse and VP over A is perpendicular. Okay, so by using cos relation with velocity we find the VP. Here you see cos theta is equal base over hypotenuse. So our base is VP and our hypotenuse is VA. We know the VA from this. X dot is equal 300 mm per second. So here you see we multiply cos theta multiply by VA, we get the VP. So our next step is to find the VP with respect to A. By using the sine relation, sine theta is equal perpendicular over hypotenuse. So our perpendicular is VP over A or our hypotenuse is VA. Here you see by using this relation we find the VP over A. Okay, so in next step we find the angular velocity of the rack AB. So you know that V is equal R omega, so omega is equal VP over A over R. Here you see the velocity is this and the distance PA is this, which we found already 774.6. So here we find the angular velocity of the rack. Now we find the velocity of the gear, which is omega at point O. At this point we find the angular velocity, which is equal VP over R. Here VP we found, which is 290 radian per second, not radian per second, it is millimeter per second, and the distance between OP is 200 millimeter. So by dividing this we found the angular velocity of the gear 1.4 radian per second. So you see this is a simple problem but tricky. Okay, so you need to pay attention to solve this.